So as we've been talking about surface temperatures, one of the things that happens to warm-blooded creatures like ourselves is if it's windy outside, the wind makes it feel colder than it really is. And this is what I always think of when I think of wind chill temperatures. I think of kind of a bare arm out here, like a Homer Simpson arm. And warm-blooded creatures like ourselves kind of ooze thermal radiation because we're warm-blooded. So here's my oozing thermal radiation. And as we walk around, in our daily lives, we count on kind of have a certain amount of this thermal radiation kind of hovering over our skin. Well, along comes the wind, and it whips away that kind of blanket of thermal energy, and it makes us feel colder than we really are. I should say it makes us feel colder than the thermometer says it is. Now, things that don't ooze thermal radiation, like your car battery, it does not care if it's windy or not outside. Okay, so that's kind of I think, thing to kind of get under your belt. So we're going to see here a table in a minute, and it is going to take in consideration the current temperature, what your thermometer is reading, and the current wind speed. And then it's going to translate it to a feels-like temperature to us as if it were just a gentle breeze, like a 3-knot wind. So what I'd like to do is a couple of locations. The first location is our location. So what we're going to need is current temperature and wind speed to see what they call the feels-like temperature is. Now the feels-like temperature in the wintertime would be the wind chill temperature. So let's see if this behaves for me. I've chosen to go to the Weather Channel internet site. So can you see where the current thermometer temperature is 32? I'm going to jot that down. 32 degrees Fahrenheit. That's what our thermometer says. Down here, it's got the wind from the north-northwest at a wind speed of 6 miles per hour. And they went ahead, and we're going to see if we can find this on our table too. They went ahead and said the feels-like temperature, even though the thermometer says it's 32 degrees Fahrenheit, for warm-blooded creatures like ourselves, the feels-like temperature is 26 degrees Fahrenheit. All right, so let's see how well they did. Okay, before we go on though, I want to take down information for one more location. I went ahead and, somewhat randomly, chose a place up north in Alaska. And I wanted to kind of look at its current temperature, the wind speed, and the feels-like temperature in this particular city in Alaska. So, let's see. This is just supposed to make you feel warmer. Okay, I don't know if you're seeing what I'm seeing. But the thermometer is reading -6 Fahrenheit up there. The wind is blowing about 20 miles per hour from the east. Makes sense. They're after the polar easterlies. And the feels-like temperature, the wind chill temperature is -30. Let's see if that's on our chart at all. So I mentioned the chart, and here you go. So notice that before I show you the numbers, along the top here is what the temperature of the thermometer is reading, and then along the side here is what speed the wind is blowing. Okay, so there you go. Let me go ahead, and I kind of want to circle these. So let's look at ours first. Ours was 32 degrees Fahrenheit. Now it doesn't have all of that. Notice it just it skips from 30 to 35. So we're going to kind of have to estimate somewhere in here. And the wind speed of our location is 6 miles per hour, and we'll go with 5. Okay, so the feels-like temperature is somewhere in here. And our feels-like temperature, according to the Weather Channel, was 26. See how that works? Well, let's go to that location in Alaska. Their thermometer was saying -6, so we'll go with this -5 here. Their wind was blowing at 20 miles per hour. So then you get the feels-like temperature at the intersection of those two. Okay, so the feels like temperature on this chart is negative 29 degrees Fahrenheit, which they had a negative 30, so that's pretty darn close. So that's wind chill effect calculated from your thermometer reading and your wind speed. Well, another feels like temperature, that feels like temperature in the summertime then would take into account the humidity. It's what we call the heat index. It's what the heat feels like. And the reason the heat index, the reason we need a heat index is that if we have if under high humid conditions, which means we have a lot of water vapor in the atmosphere, relatively speaking, then we will feel more uncomfortable. And the reason we feel uncomfortable is I have it kind of spelled out here. Basically, during high humidity, we feel uncomfortable because the rate of evaporation is less. And the reason it's less is because the water doesn't want to evaporate into air that already has a lot of water vapor. Okay? And what that has to do with us and our comfortability is basically, I'm going to draw an arm again, but now think summer, okay? Think summer, hot, you've been exercising, and here is a puddle of sweat. You are perspiring. We'll make a couple of puddles. Now, we perspire and we are counting on actually that liquid, we're counting on our sweat going ahead and vaporizing into little sweat vapor molecules. Ew. Okay, but if there's already too much humidity up here, that evaporation process is not going to happen. And actually it's that, and we'll talk more about this later, but it's that evaporation process that cools us down. I don't know if you remember recently I did a lecture and recorded it when I said that within the large bodies of water, within those oceans, when the water goes from being a liquid to being a gas, it takes a certain amount of energy. And actually, it's the same phenomenon during evaporation like this, evaporation of sweat. It takes a little bit of energy and it cools us off. And if it can't, if our sweat can't evaporate, basically, we do not feel comfortable. Okay? So that's kind of how that works. So under high relative humidity, we are uncomfortable. So heat index, then, you're going to see here in a minute, it has along one of the axes, it's what the thermometer's reading, and along the other axis, it's what the humidity is. Specifically, and there's different ways of expressing the water vapor in the atmosphere, but a really common one and works well for this is relative humidity. Okay, so it's kind of similar to the wind chill chart, but it's heat index. And I went ahead and picked a location that I think will be nice and muggy, and so we'll get a sense. Here is Panama City, Panama. And we're going to see if we can kind of find these, find this feels like temperature on the next chart. So now the feels like temperature is going to be a heat index issue. It's not a wind chill. So it's saying that the thermometer is reading 82 degrees Fahrenheit. I'm writing this down. And the percent relative humidity is 62%. And then the feels like temperature is 86 degrees Fahrenheit. So let's go back and take a look at our table. So like I was saying, along one side of the chart is the temperature. And notice here we have the top number is Fahrenheit and the bottom number, or the number in parentheses, is Celsius. Fahrenheit, Celsius, Fahrenheit, Celsius. Along the top we have relative percent humidity. So let's get ready to circle Panama City conditions. All right. So let's find a temperature of about 82. Oh, there is a temperature of 82, isn't there? Temperature of 82 degrees Fahrenheit, 28 degrees Celsius. and then find a relative percent humidity of 62. Well, we have a 60 and a 65, so it's going to be somewhere in between here. Kind of, oh, this kind of makes my eyes go buggy. So we're finding where they intersect. So that's why I'm going to circle these values. Remember, the top numbers are degrees Fahrenheit. The numbers in parentheses are degrees Celsius. So they're saying a corresponding feels like temperature of 84 to 85 degrees Fahrenheit. Notice that the internet said 86 degrees Fahrenheit. Oh, that's close enough. There have been some changes, I believe, to this feels like chart. But, you know, it's a real thing. Our bodies really, because of safety reasons, need to be able to cool down. So this feels like temperature with regard to the heat index can trigger some safety concerns. So notice that if the heat index is, you know, 80 to 90 degrees Fahrenheit, you need to be careful. If the heat index is 90 to 105, use extreme caution. You know, danger. Now, the heat index, again, that's considering the temperature your thermometer reads and the humidity. 105 to 129, you're really in trouble. 130 or higher, you're really, really in trouble.